Hello everyone, our lesson today is lesson 4 in trigonometry, which is angles of elevation and angles of depression. Okay, first, if we have two friends like Ahmed and Muhammad, Ahmed in the ground and calling Muhammad from the third floor. Okay, here, if we have here Ahmed and calling Ahmed in the ground here and calling Muhammad from the third floor. Here is Muhammad. Okay, we have here angle, which is angle of elevation. Again, we have here angle, which is angle of elevation. Okay, and this is the height of the building. Okay, it makes right angled triangle. Okay, so we have here the angle of elevation. It's the angle between the horizontal, which is AB, and AM, okay? And the observed eyes, so here we called angle of elevation, okay? If Muhammad looks at Ahmed, we have here imagine line, okay? So we have here depression angle. We have here depression angle. So here we have depression angle. So here elevation and here depression. Okay, and in this lesson also we talk about the right angled triangle, and it depends on solving the right angled triangle. Okay, here if Ahmed here is more close to the building, so here the angle is increase. Okay, we use it in the example. So we have here, for example, we have two angles like 30-degree and 40-degree, and we have here 2 points. So of course here we have, here is the smallest angle, which is 30, and here is 40-degree. Okay, so if we more close to the building, the angle will increase. Okay, if we talk about house, tower, rock, mountain, hill, all of this, we talk about horizontal and height. We talk about, again, horizontal and height. Here we have horizontal and here is the height. Okay, here is the base, which is the horizontal. Okay, and here is the height. Let's take some examples. Number 1, from a point on the ground. So we have here point on the ground, okay, at 20-meter distance from the base of a house. As we said, house, mountain, hill, tower, rock, we write perpendicular like here. Okay, so here we write perpendicular, it means right angled triangle. So first right angled triangle, we have here right angled triangle. Okay, here is a point on the ground at 20 meters from the base. So as we said here we have the base, so here 20 meters. Okay, it was found that the measure of angle of elevation, we said before here angle of elevation, which is 27-degree and 43 minutes. Okay, we want to find the height of the house, which is the height of the house here. Let's call the triangle ABC. So we want to get the length of AB, which is the height of the house. Okay, again, first write the right angled triangle and write the data on it. Okay, okay. As we said in the previous lesson, solving the right angled triangle, we want to get AB, and we know measure of angle C and the length of BC. Okay, here, what is the relation between the angle and AB? It's opposite. And here, BC and angle C is adjacent to angle C. So we have here opposite and adjacent. So we use sine or cosine or tan. Of course, we use tan. So tan angle C equals opposite, which is AB, over adjacent BC. Okay, substitution. So we have here tan 27 degree and 43 minutes equals AB over BC, which is 20. Cross multiplication here, 10 over 1. So we have here AB times 1 equals AB equals 20 times 10, 27 degree, 43 minutes. Using your calculator, the result will be 10.5. Okay. Nearest to 2 units, it means here the result will be 10.5. Okay. Nearest unit, it means we get the whole number. So here 5 give 10 1, it will be 11. So we have here 11 meter. So AB is 11 meter. So here the height of the house is 11 meter. Okay, let's take another one, number 2. A person observed from a top of a hill. So we have here from a top, okay, of a hill 2.56 kilometer. Okay. A point on the ground, he found its depression angle. So also we have right angled triangle. Here we have right angled triangle. Here 2.56 kilometer. Okay, here we have depression angle. As we said, here depression angle, it means we have imagine horizontal line. So we have here imagine angle, depression angle, which is 63 degree. Okay, here what did you notice? Here we have the horizontal line here is of course parallel to, let's it BC. So here the horizontal line AD parallel to BC. So we have here measure of angle DAC equals measure C, two alternated angle. So we have measure of angle C equals also 63 degree. Okay, find the distance between the point and the observer. Here we have the point and here the observer. So we want to get the distance between AC. Okay, here we want to get here the distance between the point and the observer, which is AC. Here BC is the distance between the observer and the base. Okay, here we have here angle C and opposite. We want to get here, of course, 90 degree. So we want to get the hypotenuse. So here we have opposite and hypotenuse. Using what? Sine or cosine or tan? Of course, using sine. So here we have sine C equals AB over AC by substitution. Sine 63 equals AB, which is 2.56 over AC. Also here sine over 1, cross multiplication. So AC equals 2.56 times 1 over sine 63. Using your calculator, here don't forget brackets. Okay, so the length of AC approximated only will be 3 kilometer. Here calculator will be 2.873. As we said, nearest 2 units, so we want to get the whole number. Here 8, so increase 2, it will be 3. Okay, the last example. From the top of a rock, here also we have top. Okay, of a rock of 50 meter, so we have here height 50 meter. Okay, and here is the right angled. Okay, The measure of two angles of depression of two sailboats are 32 degree 10 minutes and 49 degree 30 minutes. So we have here two angles of depression. So we have here 2 points. Okay? Okay. Here, as we said, angle of depression. So we have here, imagine, horizontal line. Let's set here A, B, C, D. Here, we have here 2 points. So we have here two observer. Okay, here we set sailboats. So we have here two sailboats. So here, CD is the distance between the two sailboats. Okay, here we have angles of depression. As we said, angle of depression, don't forget to write, imagine, horizontal line. As we said in the first, here, in the first, if you more closed to the building or to the hill or to the house, the angle will increase. Okay, as we said here. So here in our example, here we have the angle, the greatest angle, which is 49 degree and 30 minutes. So here, of course, we have here is the greatest angle, which is here 49 degree and 30 minutes. And here, this angle will be the smallest, 32 degree and 10 minutes. And as we said here, we have two parallel lines. So we have here measure, which is 49 degree and 30 minutes, is the closest to here the rock. Okay, so here is the greatest, 49 degree and 30 minutes. And here 32 degree and 10 minutes. Okay, here we want to get the distance between sailboats. Here we have the first sailboat and the second. We want to get the distance between them, which is the length of CD. Here we have two right-angled triangle. First, the biggest one, which is ABD, and the smallest one, which is ABC. So first, we talk about the triangle ABD. Get the length of BD, then in the triangle ABC, get the length of BC. From subtract, the result will be DC. Okay, again, we get the length of BD first, then the length of BC, then get the length of DC, which is BD minus BC. Okay, in the triangle ABD, we have here measure D 32 degree 10 minutes, and we have 50 meter, and we want to get BD. BD is adjacent, AB is opposite and adjacent, so we call tan. Okay, so here tan D equals AB over BD, substitution. So tan 32 degree 10 minutes equals 50 over BD, here over 1 using cross multiplication. So BD equals 50 times 1 over 10, 32 degree 10 minutes. So BD here approximated, it will be 79.5 meter. And here is number 1. Okay, in the triangle ABC, we want to get BC. Okay, and we know this angle. Here we have opposite and also adjacent. So we call tan. So tan angle ACB, okay, equals AB over BC, substitution. Tan 49 degree 30 minutes equals 50 over BC, here 10 also over 1, cross multiplication. BC equals 50 times 1 over 10, 49 degree 30 minutes. Don't forget to close the brackets. So BC will be 42.7 meter. So here we have the length of BD and the length of BC. By subtract, we get the length of DC. So the length of DC equals 79.5 minus 42.7. The result will be 36.8 meter. So we have here the distance between the two sailboats is 36.8. Okay? Thank you.